There are a few ways to think about the edge of the solar system. One is with the extent of the solar wind. This is the constant flow of charged particles gushing out of the sun at 1,000,000 miles per hour and bathing the planets. The wind forms a giant protective bubble around our solar system, known as the heliosphere. This huge region surfs through the Milky Way, shielding us from interstellar radiation and creating an environment that helps life on Earth to flourish. But its borders aren't fixed. Around 11 billion miles from Earth, far past the planets, solar wind pushes against interstellar space. Scientists have been monitoring this boundary over the past decade, and they're seeing it change with the sun's activity. Roughly every 11 years, the sun's magnetic field ramps up. This is known as the solar cycle, and at the peak, the sun's magnetic poles flip. North becomes south and vice versa. This cycle causes the sun's activity to sway from calm to turbulent with an abundance of flares and eruptions, which in turn affects the solar wind. Changes from the sun can make the solar wind gust hard. When it does, the heliosphere expands like a balloon. Over the past solar cycle, scientists mapped what that looked like. To understand these maps, you need to know how we observe the edge of the solar system. Scientists use NASA's Interstellar Boundary Explorer, or IBEX. About the size of a bus tire and in the orbit around Earth, IBEX maps the heliosphere with a process similar to sonar. But instead of using sound to detect objects, it uses the echo of solar wind variations. For example, starting in 2014, there was a huge and prolonged increase in solar wind pressure. NASA spacecraft near Earth detected solar wind gusting 50% harder than previous years. After traveling outward for a year, solar wind hit the edge of the heliosphere. First the termination shock, and then it entered the heliosheath, that's encased by the heliopause. Solar wind particles spent another year or so in this region. Some collided with interstellar gases in the heliosheath and turned into energetic neutral atoms, or ENAs. ENAs travel in all directions, some even back toward Earth. And between 2017 and 2019, a few of the returning ENAs reached IBEX, an echo of where the boundary is and what it looks like. If you cut the heliosphere and laid it out onto a flat surface, this is what you would see. This is the nose, and this is the tail. The nose shows high ENA fluxes, which indicate a strong gust of wind and the heliosphere ballooning. From tracking this expansion, scientists found that the nose and tail were not symmetrical. If we compare the maps, ENAs from that big 2014 solar wind increase have returned from the nose, but they haven't returned from the tail yet, suggesting that the tail is much farther away from the sun than the nose. This indicates that the heliosphere looks more like a comet rather than a round bubble. Having a full solar cycle of observations of the heliosphere opens doors to understanding the only environment we so far know can support life. And there have been a few surprises. Beyond the heliosphere, near the nose, there was one region that took 2 years longer to respond to the 2014 increase of solar wind. Scientists think these ENAs bounced out of the heliopause and into interstellar space before heading back toward Earth. These are signs that we're still learning about the quirks of our heliosphere. But one thing's for sure, these characteristics could tell us about the key ingredients for life around a star.